Hello, how are you? We are finally at the last lesson. It summarizes everything we have learned about solving triangles and some examples. Uh, so today is our last lesson. Congratulations, you did a great job in this hard circumstances. Um, Tomorrow and after tomorrow, I'm going to give you some review questions for the course. Then on next Thursday and Friday, we're gonna do the culminating activity, which will be like 6 to 8 questions, maybe 8 questions of everything we have covered. It is nothing to worry about. You're just gonna have open notes, open books, open videos, everything. So you will have no problem doing the assignment. And this will be the last thing we do this semester. Okay, I hope all of you stay safe and in good shape. Okay, so solving triangle. If right triangle, we use this is to solve a right triangle. So when we have a right triangle, we use SOHCAHTOA to solve it. Okay? The other branch, not a right triangle. And this goes into two things. We use sine law or cosine law. So if it's not a right triangle, we are either going to solve using sine law or cosine law. So how we use, when we use sine law, we have two sides and angle not included, which is this. Like I know these two sides and this angle. The second case, if we have two angles and one side, like we know this angle and any of these sides, we use sine law. Cosine law, we use it in two cases. One, if we know two sides, this is two sides. We know two sides and not included angle or non-included angle. Like and included angle, sorry. So if we know two sides and angle that's in between them, we use cosine law. The second case, if we know three sides, we use cosine law, three sides. So this is the summary of all the solving triangles. Right triangle, not a right triangle, we have two cases, two sides and angle not in between, we use sine law. Two sides and angle in between, we use cosine law. Three sides, cosine law. Two angles and one side, we use sine law. Okay? Now, I want to give you an example that cover everything we have learned about solving triangle. So example, find this in steel buildings. A, B, C, D, E. This is an isosceles triangle. This is a right triangle. This is an equilateral triangle. This side is 6.2 and this angle is 37 degrees. We need to find the amount of steel, so the sum of all these sides with this information. So we need to find all the sides that are here. Okay, this is what we have. There are some information we can get from this. The first thing I can say, since this is an equilateral triangle, I can say that these angles are equal and each one of them equals 60 degrees. So this is one thing we can say just by looking at the shape. So I need to find all the sides, and here when I have a question like this, I don't know maybe where to start. Can I start by finding this side, this side, this side? Actually, I don't have enough information here. Here I have no angles, no sides, and here only 3 angles, and I don't know any of the sides. So I cannot start to work in here. I will work with this triangle because I have one side and I have one angle, and this triangle is a right triangle. So when I look at triangle ABC, it's a right triangle at C. So this is the hypotenuse. For the angle I know, this is the adjacent, this is the opposite for the angle I know. So I can find this side and this side using SOHCAHTOA because it's a right triangle. So I can say that in here, if I want to find the length of AC, AC is adjacent because it is next to the angle and not the hypotenuse. And I know the hypotenuse, so I will use cosine, CAT, adjacent and the hypotenuse. So I say cosine 37 equal AC over AB, which is 6.2. So from here I can say that AC will equal 6.2 times cosine 37 degrees, and I can use the calculator. Make sure your calculator is on degree mode all the time. So 6.2 times cosine 37. This is 4.95, so almost 5. So we now found that the length of side AC is almost 5. Now I want to find AC. So this side is 5 now. I can use two things. I can use Pythagorean theorem. This is a leg, so I can say C squared minus A squared equal B squared and solve for that. Or I can use sine of this angle because it's a right triangle, so I still can use sine. So I would say sine 37 equal BC over 6.2. That means BC equal 6.2 sine 37. And then I will use the calculator and find the length of BC. So 6.2 times sine 37, close bracket, hit enter. So that will be 3.7. So we found this side is 3.7. Notice here, if this is 3.7, all these sides are 3.7 because it's equilateral triangle. So I found this one too, I found this one too, and I can get this angle. If this is 90 degree and this is 37, I can find this angle easily because they add up to 180. So this angle is 53 degrees. 53 plus 37 plus 90. And also I can find this angle because the sum of these 3 angles, those are adding up to 180 because they form a straight line. So I can say that the angle in here will be 67 degrees. 60 plus 53 is 113. So this is 67 degrees. Okay, so I know that this side is also 3.7. This angle is 60, 60, 60. This side is 3.7 as well because it is equilateral triangle. This is 67. Notice, this is an isosceles triangle, so this angle has to equal this angle. So this is 67 and this will be 67 as well. Now, when I look at this triangle BDE, let us have this here. EBD, this triangle. This angle is 67, this is 67, and this side is 3.7 because it is common in both, and this is 3.7. I want to find the length of this side and this side, and if I get one of them, I know the other because they are equal. So what I use here, can I use SOHCAHTOA? No, I can't use SOHCAHTOA because it's not a right triangle. I don't see a right angle. Can I use sine? So I have to use sine law or cosine law. Now, how I decide what I have? I have two angles and one side. So two angles and one side, that means sine law. So I would say, let's say BE, the length of BE over sine 67 degrees equal, oh, if this is 67, I can get this one, 67 plus 67, 143, I guess, so it is 54, 67 times 2, yeah, 143, 46 degrees, because the sum is 180. So I will say that equal DB, the opposite to this angle, which is 46. Now we know it. So BD, which is 3.7, divided by sine of 46. Now we can isolate BE. So BE will equal 3.7 times sine 67 divided by sine 46, and we can find this. So 3.7 times sine, no, 3.7 times sine 67, divide that by sine 46. So that will be 4.7, and if this is 4.7, this also 4.7 because they are equal. Now we can find the length of this truss, all the sum of all these sides. So the perimeter, so the length of iron needed for this truss will be 5 plus 6.7 plus 3 times 3.7 plus 2 times 4.7. If you do this calculation, you will get 31.7 meter. Okay, this is an example that shows everything you need to know. If we have two sides and included angle, we would use cosine law. Bye.